Newton's first law. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. And this is an example of Newton's first law.
Newton's second law. Force is equal to the change in momentum, mv, per change in time. For a constant mass, force equals mass times acceleration. F equals ma. Glue that
on. We're about to show you an example of Newton's third law of motion. As you can see, we have Cole on the four-wheeler and Tanner on the golf cart. And in Newton's third law, it states for every action, there is an equal and opposite reaction. So let's see what happens. As you can see, there's an equal reaction in both vehicles.
Okay. Every object stays in a state of rest or in uniform motion in a straight line unless it is acted on by an outside force. As you can see, the car is going to be moving in a straight line until it's acted on by an outside force with the brakes. Now Cole's just letting it roll, but in a second he's going to kick on the brakes, which is going to be the outside force. There we go.
Okay, we're going to see some real hitting now. We have Amy Watkins and Emma Williams. Emma's going to be running the ball, and they're going to hit. Ready, set, go. Yeah! Newton's first law. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it.
Okay, Tanner and QD are both holding swings, and as Newton demonstrated with a ramp, he rolled the ball down the ramp and it went up the other ramp to the same height, to the top of the other ramp, no matter what angle it was at. So, they are going to drop the swings, and they're just going to keep swinging back and forth unless acted on by another force.
Another force is the dog.
QD's is still going, as you can see.
Newton's third law. For every action, there is an equal and opposite reaction.
As Andy pushes down on the floor pushes back, causing Andy to move, aka walk. An object will stay at rest unless an outside force acts upon this object.
As you can see, the cue ball is at rest until an outside force acts on it. Andy's outside force.
Second law of motion. Now, second law of motion states that the strength of a force is equal to the amount of mass involved multiplied by any acceleration applied to it. That sounds a little complicated, but I have a simple demonstration to show you how this works. I have two objects. One is red and one is yellow, and that's neither here nor there. But this one is heavier, and you're going to have to take my word for it. I've got something inside the red ball, which does make it a bit heavier, and there's nothing inside the yellow ball. So I have two different masses, a heavier one and a lighter one. And I draw your attention to our high-powered air cannons, which I have here on the stage. Now, what I'm going to do is I'm going to try and move these, accelerate these objects across the stage, using exactly the same amount of force. So I'm going to put one of our objects, the heavier one, here, and our lighter object here. The force is going to be exactly the same behind each object. So I'd ask you, which one do you think would go faster and farther? Again, the force is the same, but our objects have different masses. If we look at that second law of motion, it says the strength of a force is equal to the amount of mass involved multiplied by the acceleration. I don't want to give anything away, but let's actually try this. Now, I've done something a little risky here, which is I'm pointing them at Parnelli, who delivers our programs here, has graciously accepted the job of tester for this. I've loaded him up, and we're going to fire these directly at Parnelli, and he's going to see which one is going to travel faster and farther. You okay with this? You're good? Good, because your contract says you're allowed to do this. So we're going to arm our system. We're going to put in some air pressure, so there's enough to, that should be more than enough. And we're going to do a quick countdown and fire these at our brave volunteer and see which one is going to travel faster and farther. All right, we're going to go 3, 2, 1, and... Could you tell which one was going faster and farther?
I had my eyes closed.
I did notice that you had your eyes closed, but I can tell you without a doubt the yellow one, the lighter one, was going faster and farther. So, what did we have? The yellow one. The yellow one went faster and farther than the red one because, of course, it's lighter. It takes less force to move something that's lighter. Now, not only do we see this in rockets, you want to have a nice light rocket to go into space, you actually see this in everyday life. With the price of gas going up, you'll notice people are trading in their heavy trucks for lighter cars because it takes less force to move that lighter object. So again, something that we're going to be seeing a lot more of. If that price of fuel keeps increasing, we want to try and find a really efficient way of moving ourselves around.